Hello, everyone. Good morning. How is everyone doing? Good morning, good afternoon, good evening, from wherever you are joining. Thank you so much for joining today for yet another session. As you know, Ashish is still on vacation. He's in Dubai, coming back this weekend. Uh, so we have another guest speaker today talking about the topics that we have today. That is load balancers and uh, yeah, both ALB, NLB, and he is a networking specialist at AWS. So let me see who all are joining. Please let us know from where you are joining and what's the interesting thing that you did last week, or what did you learn last week. Hello, everyone. Hey, Ivan. Hey, Ranga. Cool. I see quite a few people joining. We'll give another minute for everyone to join. Hey, Puran, joining from Qatar. Wow, that's awesome. And it shows that you're the first time chat. So yeah, feel free to be more active on the chat. Feel free to interact with everyone and feel free to ask questions. Good morning, Shashik, Bangalore. Hey, Ivan, welcome from Ukraine. Without further ado, let me introduce the speaker for today, Ashutosh. Hello, Ashutosh.
Hi,
So Ashutosh
Prashant.
is the networking specialist at AWS. I'll let him introduce himself to you all.
Hello, everyone. Good morning, good afternoon. Thanks for joining. So, coincidentally, it is April Fool's Day, but we are serious here, and will go through some of the stuff which is actually close to my heart because I did networking throughout my career. So, just a little bit of intro from my side. I'm Ashutosh Pateria. I'm one of the solution architects with AWS. So I support my customers in Europe region, mainly with networking related issues and architecture in general. Um, so today we have a couple of topics which we'll go through and we'll try to just see some patterns, some anti patterns, and something which is kind of written in documents but it's not very clear, so some actual practical tips which you can use in your real life while architecting, and you can just refer these to make your design a little bit better, right? So, since this is a networking session, I'm assuming that everyone has a basic understanding of networking. What is an IP address? What is a CIDR block? What is a subnet? What is a VPC?
Yeah,
Uh,
Ashutosh, actually, in the previous sessions, Ashish did take some of these primer. So we are hoping that audience would be knowing those things. So yeah,
okay,
these
that,
are 8 series session. So in the
yeah,
first seven, Ashish, the first couple of sessions, Ashish did cover few of the basics of networking from the very scratch. So we are hoping that
that's
people would be aware of IP addressing, subnetting, or the OSI model, all those kinds of stuff. But yeah, before we start, how I know Ashutosh is that me and Ashutosh joined AWS on the same day. That's how I got to uh, know Ashutosh, and like I come from a development background, and I do not have much of networking exposure. So Ashutosh has been my go-to person for all the networking queries in the last 3 years. Um, so yeah, it's an honor to have him here. Like 'cause he works day in and day out with customers, actually solving one of the most complex problems that the customers have in their like AWS network and even hybrid network. So yeah, I think Ashutosh, I'll share I'll put your stream onto the
yes, please.
stream, and I'll remove myself, and I'll hand it over to you to get started.
Thanks, Prasad. Okay, so is everyone able to see my screen? Uh, think yes. Okay, that's great. Okay, so this is week 8 of our technical sessions. So in this we have uh, we have tentatively 2 hours. We'll go through a mix of some theory and some hands-on, and at the end I have something very interesting for you. So I since being in networking, you get little privileges in AWS. So what I noticed in my 3 years working with AWS, that you can simulate most of the things except direct connect. So direct connect is something which is actually physical thing, right? So it's a fiber connection from your data center to AWS, and that is something you just read about. You don't get a hands-on on direct connect. Luckily, I have a rack here in one of our London direct connect peering exchanges, so which I reserved for today's session. So I'll just go through the whole direct connect ordering process, how it feels like, and we'll provision the direct connect, and we'll send the traffic from the data center, like from on-premise to AWS and AWS to on-premise, just to give you a feel of how it actually looks like in direct connect. It is actually very simple, but since we don't get to do the hands-on, it feels little bit complicated. So the idea is to give you um, uh, a feel of the direct connect. So we'll take questions at that time if you have any, and I'll give you some tips and tricks also. Right now, first topic of today is auto scaling, right? So AWS has a service called auto scaling. So we'll go through it, some use cases, what are the types, and various components of it, and how it actually works, and we'll have a little demo also how to configure, because in AWS, more or less configuration is the easiest part. You need to understand the logic behind it, and how to use it in your day-to-day design, right? So what it is actually, so in a plain and simple term, it is a service which continuously monitors your applications and automatically adjusts the capacity of your servers based on the predictable performance of your application, right? So you have, suppose, one web application which does, suppose it is an invoicing application, it is running on so you baselined it to run on 5 servers. Now this auto scaling service will make sure that you have those 5 servers always available to give your customers the best performance, because if the server farm has less than 5 servers, then your application might drop few of the customer requests, right? So that this auto scaling group is an auto scaling, rather, is an automated process of scaling up and down your resources. So it works with, most popular is for EC2 instances, but it works with EC2 instances, ECS tasks. You can scale Aurora replica with it. You can have DynamoDB tables and indexes, and EC2 spot fleets also you can scale up and down. Right. So it it has a couple of components, so just don't worry too much about theory, but I want to give you an overall, these are the building blocks which come together and make the auto scaling feature as such, right? So just don't focus too much on the terminology, but just try to get the idea, right? So it has three main components. One is group. So it is a logical collection of your instances, your compute instances, wherein you mention that you need minimum number of instances, you need these many maximum number of instances, and these are the desired number of instances. So logically it becomes a group of your your a pool of your EC2 instances. So which is called group. Like group is a pool of members, right? So we call it auto scaling group. Then, as you know, with every EC2 instance, when you launch, it needs to have a minimum components. Like it needs to have some operating system. We call it AMI, Amazon Machine Learning Image. Sorry, Amazon Machine Image, and it needs to have some sort of hard disk. We call it EBS. So it should there should be some boot volume attached to it. And if you want to use SSH, it needs to have key pairs. It needs to launch in a VPC. So you need to have a VPC also. You need to have your um, subnets, which subnet you are going to launch this into. So all this configuration we package in the configuration template. We call it the launch template. So launch template, configuration template, more or less are the same. They are actually the same thing, but the new term is the launch template. So it helps. So you can remember like this: when you launch an EC2 instance, you need a launch template to launch that EC2 instance, so that it picks the data from that template and it launches the new instance based on the data which you have already provided. And the scaling options, right? So auto scaling provides you various ways of scaling your services up and down, right? You can have based on a schedule that every day at 6 p.m. scale my instances from 10 to 100, or maybe based on some uh, previous historic performances that you know a trend that every week, Monday, Tuesday, your service demand is low, but Wednesday, Thursday, Friday, it is high. So based on that predictable demand, you can increase it, right? You can have it dynamically also. It will keep on tracking your compute fleet, and based on the triggers you have mentioned. Suppose number of connections or memory on your servers or the CPU, right? Based on that, it can generate a CloudWatch alarm, and that will trigger the scaling policy, right? So it can trigger, suppose you baseline your application which runs best when the CPU performance is at or below 60%. So when it hits 60%, you can start the scaling so that your customers still have better experience, if not best experience, and none of the incoming request gets dropped because you have more servers available because the scale out event has already been triggered, right? And this service is free of cost. So you don't pay anything for it. You only pay for the AWS services which you are consuming. Suppose uh, after scaling event, you are scaling 5 new EC2 instances for 2 more hours, right? Then you just pay for those instances and the EBS volume you use, right? Now let's let's discuss little bit about, sorry, auto scaling groups. So it looks like it looks something like this, right? So you create a group wherein you mention that uh, I need minimum one instance. Obviously, you need at least one instance, but this is just an example. In real life, you will have hundreds of thousands of instances. But for your application, so suppose this is a group we created, we need minimum one instance. Maximum scale, it can scale out to 4 instances, and desired capacity is 2. Now there is very interesting thing in here, like when you say that we want to give our customers the best experience, why not keep on scaling out if demand increases, right? Because if customer needs, suppose our customers are increasing and we are hitting more traffic and we have limited it to 4, in this case 4 instances, and if these instances are overwhelmed, then customers will have the bad experience because new requests might be dropped, right? So this is actually a fail-safe mechanism. So consider a scenario wherein your application, your public facing application is DDoS. So it is there is a DDoS attack, distributed denial of service attack, right? So what it does, it sends from hundreds of thousands of compromised machines, mobiles, whatever, those client devices are, legitimate requests. So suppose it is a web application, so legitimate web requests to your website, right? Since it is legitimate, it your system may or may not be able to detect that it is a DDoS, right? There are some machine learning mechanisms, and we have services to detect, even the HTTP request is properly formed, it can detect based on the pattern it's a DDoS, but that is for some other day. But it will send the request, right? Now, if suppose there is no maximum size, right? So you we
Ashutosh,
yeah.
sorry, just one thing. Uh, there's a request to there's a small, like a window you are sharing your screen on the main screen. If you can remove that, if it's possible to
Oh,
minimize
this.
it. Yeah, yeah, yeah.
Oh, I'm so sorry.
No, no problem. And second is there are a couple of questions on not able to, if you can clarify what a minimum size and desired capacity, what's the difference
Okay, okay.
between that two?
Yes, sorry, actually it's in the second screen, so I
No
have.
problem. Yeah, please go ahead.
Yes. So see, minimum is you need to have these many instances to make your auto scaling group work. Otherwise, auto scaling group will terminate. Essence like, if you do not have minimum number of applications, sorry, minimum number of instances, then your application will not work, right? So uh, let's take one example. So you have some application, and you baseline that application that it works with, if I have at least two servers, or one server, it works. So you need to have those minimum number of servers available for that application to work, right? So this is the minimum we define, right? If we don't define minimum, then these services, uh, if they are getting terminated, auto scaling mechanism will not mitigate it, right? So if you did not put the minimum number, suppose here in this case one, automatic scaling group, auto scaling mechanism will not know that we need to maintain the minimum number, and it will not try to spin up a new instance because you did not mention the minimum number, right? Desired capacity is the capacity wherein it will try to keep the number of instances at the desired number of level, but at a minimum, this is a guaranteed, right? So minimum number of instances will already be there, right? Now I was telling about this, the DDoS attack scenario, and this is very interesting actually, because you might see this in your real life as well, right? So suppose we did not mention maximum size, or maximum size is maybe too big, so maybe 100,000 instances it can scale to, right? So what happens in case of DDoS? Your system will try to, your application will try to absorb that attack. So suppose your instances are capable of catering to 10,000 requests per second, which is fine. So four servers, you have two servers or four servers you have spin up, they are able to absorb 10,000 requests per second. A DDoS attack started, then it increased to 20,000 requests per second. So auto scaling triggered because servers, suppose you have created a policy that if CPU goes beyond 50%, spin up four more instances or 10 more instances. So for 20,000 requests per second, it will keep on increasing your capacity. So instead of four instances, now you have say 10 instances. Now 50,000, you have 100 instances. Now it is maybe 100,000, 1 million. What will happen? It will keep on increasing your capacity, so your EC2 instances in this case, to a massive number, right? And it will, your application will, your infrastructure will absorb that attack. So your customer experience is there. So legitimate requests, which are your customers, their requests will not be dropped because we have massive infrastructure. But the implication is you will pay for all those thousands of instances which has been spent, right? So this is a trade-off you have to work out, right? What should be the maximum size at which which makes the business sense, because you want to give the best customer experience, but it should fit your business objective as well, right? So if you see, like, if beyond this, if there is a DDoS attack, I'm ready to take a hit. My application may down for a couple of minutes, but I will not go beyond that, right? Now there is one caveat to this. So I'm not sure if we have gone through AWS's DDoS mitigation service called Shield. So Shield is basically AWS's DDoS prevention and mitigation service. So if you are subscriber to that Shield Advanced, so there are two: Shield Standard, Shield Advanced. So Shield Standard is free of cost for everyone. Shield Advanced is a paid service. I believe it is 15K per month, minimum 3-month contract. So if you are the customer for that service, you opted for that service, what will happen? It that AWS will absorb all the capacity which was spun during a DDoS. So suppose instead of 100 instances, there were 10,000 instances more, um, which were scaled during the DDoS attack. Then AWS will refund you that money. Actually, AWS will not charge you for that particular time wherein 10,000, but the downside, not the downside, but the trade-off is you are already paying 50K per month, right? So most of the enterprises are customers of this AWS Shield Advanced, because their application is critical. But just bear in mind that there is, we always say, there is no magic wand, that there is no recommended architecture, whatever fits your purpose, right? So sorry, I took little long to explain, but I thought it's important. um Now, okay, so little bit about the launch template. So launch template, as I said, it has uh, building blocks of EC2, which without which you cannot spin up an EC2 instance. But you want to have a seamless performance as well, right? So you want that template to be used by all the EC2s which you are going to spin. So you need to have a centralized governance. So what it provides actually, so the launch template provides a centralized governance model wherein you create one launch template and all the EC2 instances will be spun up using that launch template. And it is easier to roll out the changes. Suppose your requirement changes. So in the original template, you have uh, a certain family of instance, right? Now your demand changes. You want to have a different family of instance, right? Uh, so in that case, what you will do, you can have a second version of this template. So it's suppose the versioning also. So you can copy the existing template. You can make whatever changes. So earlier it was EBS volume of 100 GB per instance. Now you can have EBS volume of 500 GB. You can change a security group. You can change whatever changes you want to make. You can have it as a second version, and you can that for certain number of for new security new auto scaling groups, or you will use it as the default template for all the EC2s going forward, right? So this is what launch template provides, and obviously it increases the productivity because all the configurations are centralized. EC2s will take those configurations, and all the new EC2s will be spun up using that, right? um Now this is a sample of launch template. We'll create one, by the way, right? So don't worry too much about it, but this is how it looks like. So I just created a non-template. So you give it a name. Default version starts with 1 because this was the first one. You mentioned the instance type. In this case, I selected T2 micro. You can select whatever you want, right? Which OS you want to use. So I took Amazon Linux AMI. Then security group, somehow it does not show availability zone and all, but you can select everything, right? And then you can refer this launch template in your auto scaling, and it will, all the EC2s will use this. So just wanted to show this. Let me quickly see if there is okay. Yeah. So, you know, don't worry too much about these so many boxes in here, but just want to give you an idea how scaling out and scaling in actually looks like. So when a scaling event triggers, so that this top green thing, when scale out events trigger, so instance goes from initiating to pending, and then from pending to in service. And when it goes to in service, the auto scaling service, it makes the server the EC2 instance active, and it can start receiving the traffic. And same happens in case of scaling in event, wherein your load is reduced. Then you want to terminate all those extra instances which you have spun up. So it goes from in service to terminating to terminated state. Or maybe if there is a health check failure, then also it goes to terminating state. And you can manually also detach the instance, right? So you can just remove the instance from that group. Now there are, you sometimes you don't want the automated behavior, that you don't want instance to simply just start and become active and in service, right? You want to run some sort of scripts, or you want to monitor what is being spun, or maybe you have some sort of validation mechanism, and this is where life cycle hooks come into picture. So what it is basically, so life cycle hooks is you can break this automated process. So instead of going from pending to in service, what you can do, you can invoke lifecycle hooks, and you can run some sort of scripts. If you want to run, you want to install some sort of software, you want to take some sort of logs, or maybe whatever you want to do, right? So you can just pause this process, and then the instance goes to in service. Same you can do for the scale in event, right? When an instance is terminating, from terminating to terminate, it does not directly go. Suppose you want to take some logs, like whatever was there, you want to take a snapshot of this, you want to run some sort of analytics, whatever you want to do with it, right? You can just add a life cycle hook in here, and you can perform your analytics. So sometimes it is important, because for the compliance reason, you want to make sure whatever instance spun up or you are terminating, its contents are saved for any compliance reason, right? So you may want to take a snapshot before terminating, right? Or you want to just download the logs, like who connected to these instances, and what did they do, what API calls they made, and all, right? So you can do that. um, Now there are a couple of scaling options. uh, Obviously you can do manual scaling. So what you can do, you can go and change the size, and you can increase the capacity minimum desired, and or reduce it, right? So manually you can do, but in today's world, we normally avoid doing anything manually, right? So second is predictable scaling, wherein based on the previous performances, as I said, you can perform your scaling events. So at certain times of the week or certain days of the week, my performance is this, so I'll make sure that my servers are available to cater to new requests, right? You can have a scheduled scaling. I can give you a nice example of the scheduled scaling. So one of a very famous this food delivery app noticed that every day at around 6 they see a surge in their orders. So what people are doing when they are finishing their office, they are just ordering food on the way to their home. So by the time they reach, their food is getting delivered nice and hot, right? And they saw the pattern, right? So they scheduled the scaling. So instead of 100 servers, they need 10 times that servers, right? So they can have, thousands of servers ready when the customers need them. So at around 5:30, they already have servers spun up, so they can seamlessly cater to new customer requirements. So you can schedule it, but you need to know the schedule, right? So obviously, so this is what that delivery app did, and it is actually working good. Now we have dynamic scaling also, right? So based on certain triggers, you can have scaling out or scaling in events, right? Based on how the traffic profile changes. Now there are three ways you can change this: simple, step, and target tracking. So in simple scaling, you can have simple CloudWatch trigger, just maybe uh, EC2 CPU goes beyond 60%, trigger auto scaling event, right? If it goes below 30%, then scale in event, right? So you can have a simple scaling, or you can have step scaling. So in step scaling, based on the level of breach of the alarm which you configure, suppose CPU alarm you configure, you can scale in steps. Like if the CPU is 40%, add four more instances. If CPU is 60%, add 10 more instances. If CPU 80%, add 100 more instances. So in steps, you can do the scaling. And third is the target tracking. So it is, so you, the, uh, I can give you an analogy of, say, thermostat at your home, right? You set the temperature to 22-degree. What it does, it keeps on switching on and off your heating system, like boiler or whatever heating system you have, to maintain that temperature, right? That 22-degree. You don't have to do anything. It will automatically switch on and switch off your heating system. So same thing, you can have a target. Now target can be memory, it can be CPU, it can be anything else as well, right? Number of connections and all, right? It will make sure that level is maintained, and for that, whatever is needed, like scale in or scale out event needed, the system will take care of it, right? So depending upon your need, you can have any of these, except manual. The suggestion would be, um okay. So now quickly, why do we really need it, right? So it is easy to auto scaling. So it increases the fault tolerance, because you want to make sure that you have your application available, and if some instances they're failed for some reason, there maybe, if it is HTTP based application, HTTP daemon failed, or some services crashed, there's a memory leak, anything, then the system should automatically be able to replace that instance, and your customer experience should not be, you know you want a good customer experience, right? So it provides the fault tolerance, right? It provides the increased application availability if there is a problem in any of the availability zones, and you have some sort of capacity already planned, then your application, whatever capacity it is baseline for, it will always be available, right? And obviously it is lower cost. Now why it is lower cost? Because you have increased capacity only when you need it. It's not always there, right? So when you don't need it, it will terminate those extra infrastructure, and it will save you money, right? So it is cost effective as well. Now let's have one example of an application, right? So it is a basic web application. You have a meeting room booking. Suppose this is a application for your office to book meeting room. Now this is the usage pattern you see here. So Sunday, Monday, it is little low, but midweek it is high, and towards the tail end of the week it is little low, right? So this is the usage pattern. Now to cater to this, there are couple of mechanisms which we can use, right? So first is the traditional way. like what we do. And by the way, this is not limited to cloud, right? This is very well valid for the on-premise as well, and this is how we do in on-premise, and that's why we are there is a push to move to cloud. Now in on-premise, what we do, we baseline the application and we cater for the peak performance, right? So suppose you baseline that at the peak we need 100 servers, right? Then we will have those 100 servers always ready. Even when we need 10 servers, then also 90 servers will be sitting idle. We need 50, we'll have 50 servers sitting idle, right? So there is a big unused capacity. You are paying for it. And in cloud also, in AWS also, if you go for this option, then there is an unused capacity, right? You don't want that because it is against the well architected principle, right? So what you can do, other option is to average it out. So you have an average that okay, you need 100 servers, then maybe have around 60 or 70 servers provisioned. This has a little plus side, is it is less expensive, but it is bad customer experience, because for this time when customers need this application, their request might be dropped because there is not enough capacity available, right? So this average capacity option is also not very good. Now what we can do to avoid extra charges and avoid poor customer experience, we can do it with auto scaling. So whenever we need extra capacity, we have extra capacity. Whenever we don't need extra capacity, we terminate that instance, right? So this way the capacity and the available infrastructure is almost the same, little bit high but not that much, right? So it ticks both boxes. First is it is better customer experience, second, less cost, right? So this is what ideally you want to achieve, right? Now okay, so after this it starts with elastic load balancing. So I think let's have a quick demo of auto scaling group before starting with elastic load balancing, so that there is um, you can see how it actually works. Let me see. um what is the time? Okay, so it's like just 40 minutes, so I think we can have a demo for maybe next 20 minutes, and we can take a 5-minute break, grab a cup of coffee and bio break, and then we can continue, right? So 1 second, let me share my, just give me 1 second, let me open up my browser. Okay, so here it is. I hope you can see it. Yes. Okay. So let's have a quick demo of auto scaling group, right? We'll just you know go. We'll just create a group, and we can alter the in number of instances than the desired one. So the system will take care of recovering the terminated instances, right? So this is AWS console, nothing fancy in here, right? So this is AWS console.
Ashutosh, probably you
Yeah.
can increase the font size of the screen. This
Let me see.
you just zoom it to around 125 or yeah, something like that should be fine.
Is it good?
Yeah, it looks good to me.
Uh, yeah, sorry. Actually, this monitor actually is big, so it actually scales everything up. So for me, it might seem too big, but let me know if it is still problematic. I'll increase more. Okay. Okay, so here this is the EC2 console, right? So in the auto scaling group, what you can have, you can create a auto scaling group in here. So for that, you need some sort of launch template as well, right? So first you need to create a launch template, but it takes so this console takes you there as well. So we can start here. So maybe test auto scaling growth, right? We need to select a launch template, because without which we cannot launch an instance, right? So we need to create a launch template as well. So give it any name, version 1. This is right. So you select the OS. So currently I have one EC2 instance which is already spun up. So I'm just taking that AMI, but feel free to choose any AMI you want. So it is just asking for the operating system you want to use, right? So we have selected that. Instance type, you can select whatever instance type. So T2 micro, because you need to have instance family. Then if you want to log into it, you can select a key pair. It's not needed actually, but because we are not going to log into the instances, but for the completeness, because in reality you may want to have access to that, right? So okay, and then security group, any security group you can choose. And then whatever volume, whatever hard disk you want to attach, you can attach. So it is default 8 GB EBS GP3, but you can change it if you want. And this these are just spot instances, and all these are advanced setting. If you want to have some sort of user data, so if you remember, when you launch EC2 instance, you can prime it with some sort of, maybe you can update the software, you can download something, you can install something, and start some application, right? So this is the user data. So you can create a launch template, right? So now you can come here. Now this template is available. This is a default template. You It will ask to select a VPC, because you want your instances, they reside within a subnet, and subnet resides within a VPC, right? So you select a VPC. You select the availability zones. I have only one subnet in one availability zone, so I have selected that. If you have more, it will show you more. And currently we don't have any load balancer, so we don't want to use any load balancer. No VPC lattice. This is one of the new services. Rest all is just default. Now this is where you create the group, wherein you have desired capacity, maybe less 2, minimum capacity 1, maximum capacity whatever 3, right? You can have target tracking, you can track CPU, you can track whatever, memory and all. Next. Okay, so this is the group we created. So if you see, it is, since we have the desired capacity as 2, right? So it is triggering the launch event. So it is launching new EC2 instances, right? So it is launching 2 new instances, because it wants to maintain that capacity, right? So if you see, it is updating the capacity in here. So if we come here, we should start seeing couple of instances, right? So these 2 instances, they are just spun up using this auto scaling group. So if you just come here, you see the launch time. They'll just show like 1 minute before. If you see here, this. So these are the instances. These 2 are the instances which are just spun up, right? Just for the argument's sake, this was the old instance, right? It was around 11 hours before. So these are the 2 new instances which are spun up. using this auto scaling group, right? So here, if you come, what you can do, you can have, so in real life scenario, what you want to do, you want the automation, but you want your system admin to know what is happening. So there was a problem, it is taken care of, but you need to have some sort of log, right? Some sort of notification. So what you can do, you can create a notification. So i- i'm I'm not sure if you know about SNS, but SNS is a simple notification service from AWS. I hope you know. So here you can create a notification service that this auto scaling event triggered. Then you can have, so I created email address just for this, and create, oh, okay, sorry, fully uppercase, lowercase, so you cannot have, you can have dash, I think. Okay. Yeah, so what it will do, um let me open Yahoo. Sorry, who uses Yahoo Mail these days, but okay. Okay, so you know, I just created yesterday only this email, so that's why I don't see too many emails. So here, whenever you subscribe to any of the topics, you need to have a, you need to confirm it, because otherwise you can spam anyone's email, right? So you need to confirm. Once it is confirmed, all the scaling events, you will see an email with. So yesterday I just did some tests, and see, you will see if any an EC2 instance is terminated, then you will see a notification like what happened, what was the uh, instance ID, what actually happened, EC2 instance terminated, and if there is a new instance triggered, then EC2 instance launch. So let's give it a try now. Okay, so we have two instances which are in service. So two instances, if you see, they are healthy because the desired capacity is 2, right? Now let's go, and maybe something happened to this instance. It crashed. Let's crash it. Terminate. Right. So what it will do, it will perform the health check, whatever time it was configured. Actually, I did not see, maybe 100 or 200 seconds. After that, it will declare the instance as unhealthy, and it will try to maintain the desired capacity. Right. So come to the auto scaling group activity. Let's wait for some time, because it needs to go through the health check, and it needs to fail the health check. It's still healthy. Sorry, I should have changed this from 200 seconds to maybe 50 seconds, but let's wait. And let's see if we get any notification also. So there is a health check wait period, so it needs to expire before it actually triggers. So it is actually updating the capacity, so we can just wait for some time, and it will automatically. Maybe let's terminate one more instance to force it. Okay, so if you see, we got a notification. You can get an SMS also. I just choose email, but you can get SMS also. So an event triggered actually. So auto scaling service triggered an event. It's called EC2 instance terminate because we terminated the instance, and it goes through that health check cycle, whatever 200 300 second it was, and it declared that okay, instance is not there anymore. So what it will do, it will try to mitigate that, right? How it will try to mitigate? It will try to spin up new instances. So if you see one instance already initializing, right? So it will try to maintain that capacity, whatever you configure. So these two instances are terminated. These are old instances. New instances will be spun up. So here, if you go to a scaling group, it shows two instances. There should be two instances technically. Yeah, there is some, the dashboard takes little bit of time to update, but eventually we will have two instances. So the whole idea of this is to show you that how you can manipulate your not manipulate, not the right word, but how you can configure your auto scaling groups to maintain a desired capacity of instances. So whatever happens to that instance, maybe a daemon failed, or maybe it is somebody shut down those instances, or maybe an availability zone failed, or anything happened to that instance, your number of instances will always be available, whatever capacity you have configured, right? So see, this one more instance which is coming up now. So eventually it will have two instances, and your system admin will get a notification also. So there is a launch event, and it is launching a new EC2 instance, right? So this was little demo of, and this is the second instance. So second instance also terminated, and after some time you will see second instance launch. Okay, so second instance launch. So these are the chronological events. So one terminated launch, another terminated launch, right? So eventually you will have two new running instances. So this one and this one. These are the new instances which just started. you know, 3 months ago. Okay, so that actually is it. You can change it, right? So okay, let me show you one more thing. I told you, right? So where is the launch template? Yeah. So launch template. So suppose you want to change it, right? Modify the template. So the name will remain same, and it is whatever version 2, and you put new instance family, right? Okay, so before that, let me show you one more thing. So here, if you see, the new instance is of type T2 micro, right? So suppose requirement changed and you want a bigger instance, right? So you can go here, you can change it to a different, maybe whatever, C5 large, right? So what it will do, it will, going forward, if you use this launch template, it will launch the instance in that particular family. So this is where this mutable feature comes into a picture, that based on the requirement changes, you can modify and version control your launch template. So you don't have to just start from scratch. You can use the old launch template and you can modify it, and you can refer this launch template into the EC2 auto scaling group, right? So this is the default version. This is the latest version. You can change it, right? So this is okay. So if there are any Um, any question in this? And see that there are so many options. Honestly, I just maybe just touch the tip of the iceberg, right? The best way to learn AWS is just try it out, right? There are hundreds of uh, videos, small videos, tutorials, they are available. Just try out various things. Maybe just have one script. I'll after this I'll share some documents like a CPU hogging script, right? You run that script. When the CPU goes beyond certain capacity, you create that threshold, and you can just trigger that event. You may hog memory, right? And you can check whether your memory policy triggers or not. You can create a CloudWatch alarm and associate that alarm with your auto scaling group. So it will trigger, first CloudWatch will trigger an alarm that in turn will trigger a policy, and your instances will be scaled out. And when you stop that script, it will be scaled in, right? So you try these various things, and you can use auto scaling group with load balancer as well, right? Because we will, in the next session after 5-10 minutes, we'll see that you may have 2 instances, 10 instances, or 100 instances. In isolation they are not good, right? Because you want some sort of front end to front those instances, and this is where the load balancing service comes into picture, and this is where you can use auto scaling group as well. So you can front load balancer, uh, you can front your auto scaling group with a load balancer, so it will maintain the capacity, and load balancer will front all the requests, so you get a better customer experience. So there are various ways to how you may want to use it, right? Um so let's okay, so that's it from auto scaling group point of view. I just touch few things just to give you a flavor. Please feel free to try it out, and maybe we can take Prasad. Shall we take maybe 5 minute break and
Yes. Yeah, let's do
come
let's do
back
that.
after?
Thanks, Ashu. This is really good. Especially what you showed on the console. That was really helpful. So yeah, as Ashu said, best way to learn AWS is get your hand dirty, try different things. And yeah, Ashutosh, do share those CPU hogging scripts and other scripts.
Yes,
We have our resources sections. We will upload those in our resources sections so that people can use that.
yes,
Okay.
yes. Good.
So cool.
Um,
Let's take that. I'll share my screen. Hold on. There should be a easy way to screen. Okay. So let's take a 5 minutes break, and then we will be back. The timer starts.
sure. See you all.
See you all.
Okay.
Hello. Okay. So, Ashutosh, you're back. Would you like to switch on your camera?
Yes, I'm back.
Cool.
So let's start this slideshow. Is it?
I'll add your screen to the stream. Yeah.
Yes. Okay. Let me.
Cool. Let's start with the next part of the session.
Okay. Thanks everyone for staying in. So this is another service which kind of goes hand in hand with auto scaling service. So this is called elastic load balancing, and whatever fancy name it has. In AWS we have multiple things as elastic, but it is just a load balancer, right? So it what it does, it balances the load in a plain English, right? So what sort of load? So it acts as a front door for all the incoming requests from either it can be an internal load balancer wherein one application is trying to access different microservices, or different application the front end is trying to access your backend logic, or backend is trying to access the database, or any sort of service which a client is trying to access. um, or it can be internet, right? So from internet you have an application, whatever web application you have from internet, so you need a single entry point. So suppose you have a website, example.com, right? So example.com will be fronted by this load balancer, and there you have your members which you can use to balance the load. Sorry, it's my daughter in here. um, okay, so this is what essentially in a nutshell load balancer does. So it can be internal load balancer, which is internal facing, external load balancer, internet facing. Uh, just give me a second. See, just give me one. Open it. I'll open it later, please. Sorry, it's like charm of working from home, and it's like holiday started. Apologies. Okay, so uh, it you can have you can have auto scaling group as well, and it will take care of the unhealthy instances. So elastic load balancer actually takes care of unhealthy instances, so it will make sure your requests are forwarded to healthy instances only. So there is an inbuilt health check mechanism. So whatever members you have attached with the elastic load balancer, it will keep on tracking the health of that, right? We'll just go through the whole premise, like how it fits into the greater scheme of things. So uh, let's go to the next slide. Yeah, so see, this is a normal scenario wherein you have some customers. Let's grab a pen. So you have these are your customers, and you have some sort of server, right? So this is maybe an application you hosted on internet. So this all works when you have a small customer base, and that you have one small server, and there is no fault tolerance or high availability requirement, right? But more often than not, this is not the case, right? You want your service to be available, and there should not be a single point of failure, right? In that case, what you have multiple servers serving your content, right? And then there are two ways. So this server has some IP address. So you can front these server, you can make these servers internet facing servers, right? And you can give whatever IP address or the URL of these servers if you have a DNS to your customers. And so some customers will have this, some customers will have this, some customers will have this. This is not a very efficient way of serving your customers, because if this server goes down, then the customers need to be updated, right? And so that's why we don't do that. What we do instead, customer will be given a single URL or a single path, and it will be your applications will be fronted by a elastic load balancer. So this is where that front door analogy comes into picture. So this is the front door, right? So your request lands in here, and it is elastic load balancer's responsibility to distribute it um, to distribute it amongst all the available servers you have, all the healthy servers, right? So it will keep on tracking where, if all the servers are healthy, if they are, it will send the request, right? Now, what are the benefits? Why should we really use it? I think it is apparent, but let's go through it anyways, right? So it provides a high availability, right? Because it distributes the workload amongst multiple servers. So your application will always be available, because it is very unlikely that all the servers at the same time fails, right? So it provides you the high availability, right? And it provides you the fault tolerance as well, because higher availability and fault tolerance, they go hand in hand, right? So it is keep on performing the health checks to monitor the health of your, maybe you are health checking your daemon, you are running a particular service on a particular port. It will keep on probing that port, that okay, that, because sometimes what happens, your server might not be down, your server may be running, but that service crashed, right? So you can have that, you can keep on tracking that. And if it fails, what load balancer will do, load balancer will remove that from the active servers list, and it will only send the request to the available one. So it provides some sort of fault tolerance as well, right? And obviously better customer experience, because you have now, mm, the availability of your service is increased, and customers don't have to wait for the desired capacity when you are spinning up new servers. And the services are, the client requests are not disturbed in a way, right? So it provides a better customer experience. So how it actually works, right? So first, what you do, you have your number of servers. So in this case, we have say three web servers. Right? So this one, two, and three web servers, and you register them to some load balancer, right? So maybe this is network load balancer or application load balancer. We'll go through it. So don't worry about the term. Just consider it a load balancer, right? So what it does, a request comes from internet, somebody is trying to use your application. What load balancer will do, it will distribute that request to three servers, because all three are showing as healthy. Now what happens is, if one server goes down, suppose this server goes down, what load balancer will do, when the health check fails, it will remove that server from the active server list, and your customer request will still go through the other available servers, right? And this is where you pair it with auto scaling group, right? So what an auto scaling group will do, auto scaling group will reinstantiate a server. So it will just, this is terminated, it will terminate this server, and it will create a new server, and then health check will pass again, and it will start serving the traffic again, right? So this is how the auto scaling and the load balancer, it goes together, right? Now this is little important actually, so I want you to focus in here, because this is where normally, while architecting, you get confused, and uh, this is where we miss some of the crucial points. See, in AWS, load balancer is not a physical box. Actually, in AWS there are rarely any physical box, everything is a service, right? So when we come from the on-premise environment, right, there we see everything as a box, right? So load balancer is a box, router is a box, firewall is a box, right? And when we translate that understanding into AWS design, and AWS, it was completely different, right? And load balancer is not an exception, right? So it was differently than the on-premise. And how it is different, right? So whenever you create a load balancer, it asks you to select the availability zones, right? It asks you to select the subnets, right? So, and which in turn is it resides inside an availability zone, because subnet cannot cross an availability zone, right? So you select multiple availability zone, and the best practice is to select all the availability zones where your servers are. Because if you don't select those availability zones while configuring elastic load balancer, it will those servers will not be able to access the elastic load balancer service. Because what it does, when you create elastic load balancer, it puts an ENI. So this is an ENI. So it puts an ENI or elastic load balancer instance in that particular availability zone. So this combined is elastic load balancer actually. This is a service, right? But based on what availability zone you select, it puts the instance of that particular load balancer into that availability zone. And once you have your member servers registered with it, it will be able to send the traffic wherever it wants to, right? Suppose you don't associate, you don't select this availability zone, right? Then these servers cannot serve traffic because you do not have um, ELB instance in there, right? So always remember, the best practice is, first of all, you should, ideally it is must, right? You must create your servers in all possible availability zones to decrease your blast radius, right? One availability zone may go down, two availability zone may go down. If you have three, at least one availability zone will be. It's highly unlikely that availability zone goes down, because it is a combination of multiple data centers which are physically apart, like 60-mile, 100-kilometer radius. So but suppose it goes down, right? You still have other availability zones, so to increase your high availability and fault tolerance. And once you have multiple availability zones, put a load balancer instance in all the availability zone, right? So this is a design principle which it works without that as well. You can select one or two only. If you have say three or four availability zone, it will still work, but you won't be able to send traffic from other availability zones, right? Now there is another design uh, consideration when you configure your elastic load balancer. See, it is an elastic service, right? What does it mean? It means when your number of requests increase, it spins up more ELB instances within the same availability zone, right? What it means is, suppose this instance is capable of uh, taking care of maybe 500,000 or maybe 1 million connections per second, for the argument's sake, right? And your connections are increasing, maybe 2 million connections per second, right? So due to the elasticity of the nature, what it will do, AWS will automatically spin up a new ELB for you. If connections still increase, it will spin up new ELB. You don't have to do anything, and it will maintain the list of DNS in the route 53. Customer will still see whatever they used to see, like whatever URL example.com/abc. But AWS will take care of it, but it will keep on spinning out. So this auto scaling thing is already inbuilt as part of this service, because this is a managed service. Now this is where we normally miss, right? So what happens, as a design principle, you must make sure that whatever availability zone you are selecting, whatever subnet you are selecting, it has at least 8 available IP addresses. Because whenever these services are spun up, these essentially are the ENIs, right? ENI, Elastic Network Interface, has an IP address, because otherwise, it's not an ENI, right? If you don't have available IP addresses, you may hit a bottleneck in here, right? So that's why it is written in like very small, like one liner in the 200-page documentation, that you need to have at least 8 free IP addresses available. 8 free IP addresses available. It means /28, right? So out of those 69, so /28 will give you 16 IP addresses. Out of those, 5 are not usable. First, last, and rest for the .2 DNS lookup and for the future use, right? So 5 are not available. Remaining are 11. Out of those 11, 2, 3 maybe your servers, right? So be mindful of planning this well beforehand, right? Because you cannot change it later. You have to decommission the infrastructure and do it again. So make sure you have enough IPs available for the capacity expansion. And this is IP address planning is something, I have seen so many customers wherein, it goes completely sideways because, in AWS it just works. In 10 minutes you can spin up a 3-tier environment, and it just works. And because it works, the planning becomes an afterthought, right? And this is where we fail. So planning is very important. You have to have IP address planning properly. Otherwise, this infrastructure is not really lasting, right? Just keep in mind, right? Um, Now there is one more aspect which is called cross zone load balancing, and this is also very important, right? So what it means is whenever you have a request coming, so number of requests, if you have say two availability zone A, availability zone B, and you have number of servers, they can be same, they can be different. So here in availability zone A you have two servers, availability zone B you have 8 servers, in total 10 servers, right? So whatever requests are coming, they will be equally distributed. If you see, this is not equal in the sense like equal number of requests are coming to availability zone A, equal number into availability zone B, equal based on the server. So if they have 10 servers, then you have 10% of the workload. So suppose there are 100 requests, each server will get 10 requests. This is how we want it actually, right? So equal distribution of traffic. And this is called cross zone load balancing because it is across the zones. Zone means availability zone, right? With ALB, it is by default enabled, right? You have to disable it deliberately, right? With NLB, you have to enable it. It's by default disabled, which is, I don't know why we made it complicated, but it is what it is, right? So you remember that. If you see the uneven distribution, check the cross zone load balancing, right? What happens if it is not enabled, right? Then what will happen? ELB service will try to send 50% traffic here, right? And it will send 50% traffic here because, it is like two availability zone, 50-50. Then here it will send 25% here, 25% here, and rest all will get 6.25. This is not what we want, right? So always remember cross zone load balancing until unless you have, I don't know what business reason you may have, don't disable it, right? So just remember this. So it will result in an equal distribution of traffic. So you need to make sure that you have it properly. Let me quickly see if there is any question. Let's go. Okay. Okay. What was the? Okay, yeah. For now already answered it. Yeah. Sorry, actually, I don't see the question, so I have to toggle the screen to see the question. So thanks to my colleagues, actually, they are taking care of. And at the end, if we have some time, we'll take this question. Okay. So that was the cross zone load balancing. Now, types of load balancers. So there are three types of load balancers. Actually, there were four, but one is decommissioned. It was called classic load balancer. It was for classic instances. Honestly speaking, I never saw any classic instance. It was like early days of easy to Amazon, wherein there was a shared pool of infrastructure and everybody was using an instance within. There was no concept of VPC. So everybody was using an instance within maybe a same big VPC. That's called classic instance. But I don't know, So I never use it. Nobody uses it these days because they want isolated environment, which is called VPCs, right? So classic load balancer you won't see, but some customers, organizations, governments, they are using classic EC2s. They need classic load balancer, but don't worry, I don't think you will ever get to work on it. So mainly we have three. So network load balancer, application load balancer, and gateway load balancer. And this is where when we say like layer 4, layer 7, so these are OSI model layers. So layer 4 is the transport layer, layer 7 is the application layer, right? So let's start with network load balancer. So it works with TCP and UDP both. So these are two transfer protocols, right? So transfer control protocol and user data number. So it caters for both, and it works at layer 4. What does it mean? It means that it will not check the HTTP header, right? So whatever you pass in that header, it won't check. It will only check the destination and the port, right? So if the protocol is TCP or UDP, port is whatever 80 443, whatever, it will send the traffic, right? And that's why it is fast also, because it does not go, it does not pass all three extra layers, right? Session, presentation, and application layer. It does not take care of it, right? So that's why when you have an application which is latency sensitive and which has uh, uh, too much, well, I'm not finding the right word, but if you need um, millions of requests per second, put it that way, right? You need like hundreds of millions of requests per second, and you need some sort of load balancer to carry to it. Application load balancer will not be suitable for that, right? So network load balancer will take care of those things, because it can handle, tens of millions of requests per second. uh, so the targets can be IP addresses, it can be containers, right? It can be EC2 instances, right? And it resides within a VPC, because it needs an IP, right? And IPs are within subnet, and subnets are within availability zone inside a VPC, right? So this is called network load balancer. Just remember, TCP UDP works at layer 4. And if you have an application which needs, capacity, like big capacity of incoming connections, you use network load balancer. Now application load balancer, so it is a layer 7, right? So it caters to http HTTPS. So normally you have web applications, right? They work on HTTP protocol and HTTPS. If you have SSL, and normally everything is HTTPS these days, because you don't want to send anything plain text, right? So it's all TLS encrypted. So it works at layer 7, and the targets can be EC2 instances, containers, lambdas, IP addresses, right? So this is the application load balancer for the application. Now gateway load balancer. So gateway load balancer is basically, if you have multiple appliances, right? Then, so appliances in the sense that you have maybe Cisco firewalls, or you may have Palo Alto firewalls, FortiGate firewalls, checkpoint, whatever appliance you have some proxy appliance, and these are EC2 based appliance, by the way, right? When I say appliance, virtual appliances, right? Then it gives you the front end to those appliances. It will take care of the failure and scaling of those appliances, so you can front all those appliances with this, right? So I have separate slide for this, because gateway load balancer is very important for a number of reasons, and I'll go through, how, what are the design principles for it, right? Um, right, so this is a general comparison, like it, application load balancer at layer 7, network load balancer layer 4, gateway load balancer 3 of layer 3 and 4. But it acts as a bump on the wire, right? It does not change the packet in any way. These two changes the packet in a way, right? But this is little deep. I don't want to go that deep, otherwise it will confuse you. But it is all available in the documentations. I'll forward you, right? Um, and this is a typical placement of the load balancers, right? So you have a load balancer, then you have some sort of front end, then you may have back end, then another load balancer, and so you can distribute the traffic with these two. So this is the front end load balancer, so this is internet facing. This is the back end load balancer, which is private. You can make this placement. This is just an example. You necessarily don't have to do like this, but this is how you can do it, right? Now the gateway load balancer is actually to front your appliances, right? Now network appliances, what is a network appliance, right? So network appliance is basically, it is, in traditional sense, in your on-premise environment, you used to have some sort of proxy, like Bluetooth proxy, or checkpoint firewall, Cisco firewalls, FortiGate firewalls, or and those sort of appliances, something to logging, something to monitor, IPS system, intrusion prevention system, intrusion detection system. These are appliances, right? And you, whenever you move from on-premise to cloud, you may have your infrastructure and your personals trained on certain sort of appliances, right? Maybe your workforce is trained on Palo Alto firewall. They know in and out of Palo Alto firewall, how to maintain security, and how to do with it, right? And you want to retain those resources, and you want to just maintain that control on the expertise you already have, right? You want to bring it to AWS, right? And this is where you can have virtual version of that same Palo Alto firewall. You can just import all the policies, and then your existing workforce can manage it as they manage on premise, right? You want to do that, but it is not same as on premise, right? So in on premise, these devices, they work in clusters, and they take care of sharing the states, the flows, and they take care of the failover. But here it is all EC2 based, and there is no native mechanism to failover an EC2. Why? Because so whenever you send a traffic to an appliance, you are sending to an IP address. That IP address is attached to an EC2 instance. If that EC2 instance fails, you need to have some sort of automation, like you need to write a Lambda function to detach that ENI from failed EC2 instance and attach it to the new instance. And this is where the problem comes. And gateway load balancer specifically solves that problem, right? It will take care of, just scaling those appliances, right? So this is traditionally what happens. So you brought your checkpoint firewalls, right? So these are two checkpoint firewall. What a check? I'm just saying checkpoint name is any sort of appliance, doesn't matter, right? So, and from source to destination, you want to inspect some packet, because there's a firewall, you want to inspect packet. So your traffic is destined to the active one. Suppose this is active, this is passive. And when this fails, this ENI, right, you need to have some mechanism to switch this ENI to this, and then the request will come from here and then go there, right? And this is all manual, or it can be automated, but you need to write Lambda function and move this, and this is where the problem is. So what gateway load balancer does, it fronts all these appliances. You have multiple appliances in multiple availability zones. You send requests to gateway load balancer. It will keep on checking the health check. It will send to the desired appliance. That the traffic will come back and it will go there. So no matter how many fleet, as long as even one EC2 appliance is available, you will be able to serve it. So this is the problem it solves, right? Uh, so traditionally, what happens when you use a load balancer? If you want to send a traffic to internet, so this is suppose some website, right? You want to send a traffic. Where will you send? Suppose it is working in a proxy mode. Proxy, what it does, proxy is just a fancy term. It is just a net device, network address translation plus PAT, port address translation. So what it does, it puts an envelope on an existing packet, and it translates the IP address, right? So what it does, it will send the request. Your EC2 will send the request to the load balancer. Load balance, everything needs to be inspected, so it will send to whatever firewall. So suppose firewall 1, so the source is still there. What it does, so this is internet facing firewall, and this is typically what we have firewall at the perimeter of our network, right? So these are internet facing. So what it does, the source becomes the firewall, which is the internet facing IP address, public IP address, destination becomes that, right? And what happened here, the source is changed, right? Because there is a proxy mode, the source is changed. Now there is a concept called bump in the wire. Like bump in the wire means it does not alter the packet. So this is what gateway load balancer does. It just sits in line. It's called inline appliance. It just sits in between the source and the destination, and it will not modify the source, right? Source will still be there, destination will still be the same, right? And based on whatever uh, appliance you have available, it will send the traffic, and it will take care of the availability of these three, scaling and all, right? Now at a glance, this is how it there are few components to it. I'm going one level deep, but I think it is important to understand, and there is lot of documentation available. I'll share all the designs, because if you are working with any of the AWS designs, 9 out of 10 chances are you will use gateway load balancer in some way, shape, or form, right? And there are around 6, 7 designs wherein you can use this load balancer. So, I'm just giving you a kind of a heads up so that it's not completely, new to you. So it works based on the endpoints, and I hope you know the endpoints. So endpoints they are powered by um, private link interface endpoint. It's an ENI, and behind that ENI, we use our AWS backbone to carry the traffic to your, suppose there is appliance VPC, right? So we created a security VPC or appliance VPC. Then we have our gateway load balancer, and we have whatever firewall, proxy, or whatever devices we have, right? So these are various components. So you have gateway load balancer endpoint. This is actually an ENI, and behind that you have actual gateway load balancer, and your services. You put a route with a next, so route where in a subnet. So wherever this, whichever subnet this EC2 resides in, you put a route saying, suppose you want to inspect everything which is going out. So everything which is going to internet, 00 is like everything, go to this endpoint when the traffic comes. So there is a protocol called Geneve protocol, but it will be too deep actually. So Geneve is basically an encapsulation protocol like, GRE. So what it does, it just it creates a tunnel, it sends the packet, whatever, firewall it goes to, it inspects, drops, logs, blocks, whatever you want to configure firewall with, it does that, and it sends the traffic to the destination, right? Here in the whole scenario, source does not see any change, destination does not see any change. Everything here is transparent, right? So yeah, just remember how it works. And yeah, this term, in case you don't know, there is a nice video. If you search AWS hyperplane, so most of the AWS high available service, like all sorts of load balancers, Route 53, they work on AWS hyperplane. So hyperplane is basically a concept wherein we say, like, we have, suppose gateway load balancer, highly available service like gateway load balancer. What the hyperplane concept does is, it puts the instance of that service in every data center, like multiple racks of every data center of every availability zone of every region, right? So in a region there are, say, 2 availability zones. In every availability zone there are 3 data centers, suppose. In every data centers there are 1,000 racks, right? So out of those 1,000 racks, there may be, couple of, I don't know the actual number, but say 10 racks or 100 racks. That service will be there, right? And it will be distributed, so it can avoid the noisy neighbor problem, right? And it will have in every data center, in every availability zone of that region. So that's why this service is highly available. So for this service to fail, all the data centers in all the availability zones need to fail, which is highly unlikely. That's why we call it kind of, high available service. And these are the partners. So we have all major security partners with us, so you can use these devices. So you do not necessarily have to retrain your resources. You can use that. Um, and this is a north-south inspection. So when we say north-south, east-west, right, it is just a term in networking. Like north-south is when there's internet to your infrastructure. East-west is within your infrastructure, right? VPC to VPC. North-south is internet to your VPC, or VPC to internet, right? So suppose this is the request. So from internet, you are users are trying to access your application. It goes here, and there is ingress routing table. So now there is a feature in VPC which allows you to put specific routes in the VPC. So IGW, earlier you could not change the IGW routing, but now you can. So anything comes, you send it to gateway load balancer. How you send it? Via endpoint, as we saw. send it to gateway load balancer. Gateway load balancer will encapsulate it via Genie protocol, send it to the actual gateway load balancer. It will send it to whatever security appliance you have. The request will come back, and here it says this whole VPC CIDR is local. It will be forwarded to here. The response will go back, and wherever it came from, it will go to the appliance. It will check, because it has to be symmetric, by the way, right? So whatever appliance is being used, the traffic needs to go to the same appliance. It will take care of it, and the request goes out. So this is I'll share all these blogs. These all are publicly available information. So don't worry too much about it, right? And this is the east west. So there are so many components actually. So don't worry in case you don't know transit gateway or something. But normally we use transit gateway. So it is to connect various all the infrastructure together. So it is kind of central connectivity point, you can say, right? So if you want to go from um, FVPC 1 to FVPC 2, right? So this is how you go. So from here, you go to transit gateway. Transit gateway will forward the traffic to the appliance VPC, like security VPC in this case. Security VPC will have the gateway load balancer endpoints. It will send to gateway load balancer. It will go to appliance. The traffic will come back to the transit gateway. Transit gateway will send it to the destination, and the return traffic will follow the same path. Right? Now, there is a caveat in here actually, right? And this is very important. I have seen multiple customers, their architects, just missing this point, and this is where it goes little sideways. So AWS has an inherent policy, like internal policy within the traffic flow, that AWS will try to keep the traffic in the same availability zone as much as possible. So because of that policy, what happens if you want to send traffic from, say, source is in availability zone 1, destination is in availability zone 2. So suppose this is F1 VPC, this is F2 VPC, you want to send traffic, right? So what it will do, the traffic will come from availability zone 1, it will go to availability zone 1 transit gateway ENI, it will send the traffic to transit gateway keeping the same principle, that same availability zone, it will send the traffic to availability zone 1 where your appliance is. So suppose this is gateway load balancer, right? So your appliance, it will return the traffic, not return. So it's the same packet. It will come. Transit gateway will say, okay, where it is attached to. Now here it will switch the availability zone from availability zone to availability zone 2, because destination is in availability zone 2. So it will send to availability zone 2 transit gateway ENI, and the request will come here. So far so good, it's all hunky dory, but the problem starts now. When the request goes, it will follow the same principle. So availability zone 2, transit gateway will follow the internal principle. It will keep the traffic in availability zone 2. It will send to the appliance of availability zone 2. And all these security appliance, they are symmetric. So if there is no open socket, they will not allow the traffic to go back, right? It will drop the packet in here, because it does not know about the incoming connection. So how it can allow the outgoing connection, right? So this is called asymmetric routing problem. So it used to happen, right? So now so AWS came with transit gateway appliance mode. So you have to enable that. And by the way, appliance mode you cannot enable using GUI. So there is a command, right? If you search like how to enable transit gateway appliance mode, you can enable using CLI only for now. I need to check if it is changed, but as far as I know, you can only do it with CLI. So what happens? It will keep the traffic symmetric. So if you enable the appliance mode, transit gateway will make sure that it sends the return traffic to the same appliance or same firewall where it is came from. So this way the packets are not dropped. And always remember that, because this is, I have seen this problem, I don't know, so same problem so many times, right? So just remember that. So let's okay, we already did that auto scaling group demo, right? So okay, so let's see what is the time we have. If everyone let's quickly do it. So let's go through some load balancer demo, and after that I will give you the direct connect demo. um Give a discard. Okay, so let's quickly go through this. Okay, um so this is our same old console, right? So I have, just to give you, I have some preparatory work done. So I have two servers already spun up, right? So I call it server 1, server 2, and they are internet facing servers. So this 34.
Ashutosh, can you please increase the font
Oh,
size?
sorry, yeah, let me do that. Oh, this is too big.
Yeah, looks good.
Okay, so I have two
A bit
servers.
more, a bit more, a little bit more, and let me also make it full screen.
Yeah.
Yeah, cool. It looks
Okay.
good.
So I have two servers, server 1, server 2, just for the for the testing purpose, and they are internet facing servers, so that I want to show you something. So this is the internet IP, and this is the server. So it is like HTTP request. So this is server 1, right? So when you access that, this is a website, and this is server 2, right? Sorry, I could not make it any fancier, but at least it's a different color, so you know which one is which. So these are two servers, right? Now this is one way of doing things, right? You can give this URL. Suppose this is a URL to your customer, right? uh, uh, Actually, this is a URL in case you want to use that. But yeah, so you can give this to your customer and give this to your customer. But this is not a good customer experience, right? You want to make sure it takes care of the switchover from here to here, load balancing, right? So what you want to do, you want to create a load balancer to load balance this, right? So let's quickly create a load balancer. And yeah, actually I have already created them. So I don't know. Let's create a new one. So, oh, by the way, sorry, I went too fast. Um, Create. So, when you create a load balancer, it will give you option which load balancer you want to create. So, suppose you want to create the application load balancer. It doesn't matter actually. These two, the configuration is more or less same. So don't worry. It will follow the same principle, right? So just create the load balancer. Uh, so it is internet facing load balancer because we want to front our web application with it, and we want customers to access which VPC. So this is the base of VPC we have, where we have these two instances. And I told you, right, it will ask for the subnets which you want to use. So the availability zones, you select all the availability zones available, right? So this is, by the way, this is the subnet where I have my instance in, right? So I know it, that's why I'm selecting it, right? So these are the two subnets. So public subnet 1, public subnet 2, where I have server 1 and server 2 in here, right? Security group, I already created a basic security group. So basically that security group has two ports allowed. One is SSH port TCP22, and one is HTTP, the TCP port 80. So HTTP request, right? I have only two ports allowed in here. And then I need to create a listener. So listener is this app, this load balancer will listen on which port, right? If the customer is requesting. So if it is HTTP, it will be TCP port 80. And when it listens, where it will forward to, right? So what you have to do, you need to create a target group, right? So I have already created a target group actually, wherein I have included all these instances. But for the completeness sake, let's create a target, right? So target group is basically where you will forward that request to. In the target group, either you can have IP addresses, lambda functions, or you can have application load balancer also a target for the network load balancer. And this is a very peculiar use case wherein suppose you have an organization compliance and security requirement that you need to have a fixed IP, right? Whenever you create anything in AWS, you don't have too much control on the on the IP which AWS is assigning, right? You can have elastic IP address, but that is it, right? But if you want to have a fixed IP address, ALB does not support it. So you assign a fixed IP to NLB and front your ALB with NLB. And this is a very specific use case. And there is a lot of documentation available. That's why it is there. In case you are wondering why, how can a load balancer front another load balancer? This is what it is, right? So in our case, we have instances, right? Target group name, Besa new target group, right? Port 80, yes, we are listening on port 80. This is HTTP version, so HTTP one is common. This is the VPC you need to select. So we have a Mesa VPC where we have two servers. Health protocol is HTTP. So we are checking health, that HTTP daemon is running, because server might be up, daemon might fail, right? And this is where my website is hosted. So this is at the slash one. You can change it if you want, right? And this is the health check. So you are performing your health check on which port? I'm performing check on the port where the traffic is coming from. You can change it. So the traffic may be coming on port 80. You can perform health check on port whatever 1000, doesn't really matter, right? Depending upon your need, but we are checking on the same port, right? So if port 80 is up, it means the daemon is running, right? Now health is threshold, as the name says, the health check should pass 5 times to make that instance healthy. Health check, if it fails 2 times, instance will be marked unhealthy. With every try, it will wait for 5 seconds. An interval, let's change the interval to 10 seconds. So between health checks, it will wait for 10 seconds, right? And this is the success code. So this is the HTTP success code. Nothing fancy in here, right? Next. Now you need to register targets, right? So you created a target group, but you need to register. So I have two servers in here. So I will register these two, include as pending below, right? And create target group. So this is the target group we have, and these are the two instances we have, right? And they are unused because we created the target group, but we do not have any load balancer fronting that, right? So we need to do this. So go back here, refresh it. We have a new target group, and rest all is, this is the basic configuration which we already use. Like these are the two subnets into availability zones. We are listening on port 80 and create load balancer, view load balancer. So now our load balancer is created. So let's go a little bit up. Sorry, it is actually too big, so scrolling is becoming a little problematic. Doesn't matter. Right. So it says if requests come on port 80, forward it to Besa target group. Besa target group has two instances in it, right? So let's copy the DNS name. This is the public facing DNS name, and come here and paste it. It takes a little bit of time, so just don't worry. It will come. So let's just give it some time for that target group to have the instances healthy. So target registration is in progress. So it will take for 5 consecutive health checks, right? So it's on 10-second each. So it's around close to 1 minute, like 50 seconds. So just wait for that much time. When the targets are healthy, it will start serving the traffic. Okay, so targets are healthy now, right? So both targets are healthy. So if we go here, it should technically work. Okay, I don't know why it's not working. Oh, it is still. So it is still provisioning in AWS. Everything is little slow, but let's okay, it's active. Okay, so see, so this is server two, right? Now, if I refresh this, so another customer is coming, and it should switch, right? So the requests are cycling between these, right? So I have two servers, and all the requests are cycling between server one, server two. So it is load balancing the traffic, right? So this is a simple example of how the load balancing is working, right? This is maybe too simple, but I hope you got the idea, right? So we have two servers, it is equally balancing the load. So normally it is round robin, right? So it just selects, or secondly is the least connection, right? Least connection to the servers. So this is how it works. Now there is another uh, actually what you can do. So this supports load balancer, application load balancer supports based on the target as well, right? So what you can do, let me quickly show you. I'm sorry, we are running out of time, but I hope you can stick around for some more time. I wanted to show you something. Okay, so I created separate target groups, right? So these two target groups, so what I did, so you may have a case wherein you have, say, two servers. One server is serving a type of application, one server is serving photos, one server is serving videos, suppose, right? Or maybe invoicing application and billing application, two separate applications, right? You want, based on the HTTP header or based on the query string in HTTP, because remember, application load balancer works at layer 7, so it reads the HTTP header, right? So based on the query string or the path, you can change which server it will hit. It will not load balance in there, right? It will see which server is registered for that target where that application resides. And so what we can do, we can just check that, right? So have let's create. Actually, I think I already created one. Just a second. No, it's the old one. Okay, let's create one. Doesn't matter. So what we can do, we can create a load balancer, and this time we are balancing the load based on the query string, right? Besa internet facing IPv4, Besa VPC, both subnets, and this is security group. It's a good idea to always remove default security group, right? You don't want anything default, right? And then, oh, actually, this is in use. We need to remove that. Yes, so okay, doesn't matter. Let's see this. So I already actually used it. So in the interest of time. So this is Besa ALB. So I already what I come on, how to scroll it. Okay, so when you create, so in here, what I was doing, since I already created, I'm not going to create it again, but I'll show you, right? So here I have created two target groups. One target group is I named it server one, and wherein I registered server one as a target, and second is service two, and server two as a target, right? So what I'm doing here, I have created a rule which says If the query string is environment service variable 1, right, then the send traffic to target group service 1. If environment service 2 service and variable 2, send it to service 2, right. And if the query string has neither of these, then just the return a simple message that query string not matched, right. So, just to, for the completeness sake, so this is how you do it, right. So here you go. So you click on add rules, it will come. So add rules, right, it will, you need to insert rule, add an action. You can have based on the host header, based on the path, like slash photos, whatever, slash videos, http header. I use query string, and I said service equal to whatever 1. Then send the traffic to target group 1. Service 2, send the traffic to target group 2, right. So this is what I did, just in case you are wondering how I did it, right. uh, and that's it. So what will happen now, when, let's take the DNS name of this. What will happen if I do query string service, uh, so it is service equal to 1. See, so service, if query string says service 1, it will serve the server 1. No matter how many times I cycle it, it will not load balance across different servers, because it, this is a rule which says, because this is the application, right? We don't want it to send to the other application, right? Now, if I do server service equal to 2, yes, it's still doing its thing. So it should go to server 2 actually. That's okay. Okay, maybe something messed up. Load balancer here. This HTTP. Let's quickly just see if maybe this root server time. Maybe while saving, I made some mistake somewhere. We can figure it out. If it takes too long, then probably we'll just leave it. But just wanted to show you the idea. So the rule says service 1. Okay, so service 1, service 2, query string 2, service 2, return fixed response. So yes, this is correct actually. It should
Can you
that.
check the URL correctly? I think the URL might be having a typo.
Okay, okay. Let's copy again. So this DNS name. Yeah, because there is not much which can go wrong actually. Sorry. Question service equal to 1. Yeah, this is working. Service equal to 2. No, there's some, I don't know. Oh, it's just slow. Okay. So yeah, so now it is serving, if my query string is service equal to 2, so it is serving the another application, right? So you can have it like, you can have a path also, like suppose you have path like cat pictures, then it will show you the servers which are serving cat pictures, dog pictures, whatever, right? So this is what I wanted to show you. So service 1 will always serve the server 1, service 2 will serve the server 2. Now we have one more, right? If it does not match, so what, service 30, right? What it will do, it will just give a string like query string not match. This is just a text we have put in there, right? So this was a simple example of ALB. In NLB you cannot do any of this, right? Because this is HTTP header. HTTP is an application which is layer 7. You can only do in ALB, you cannot do in NLB. You get in NLB, it just works till here, right? So that is it from demo point of view. And if you are interested and people are available, we can go through the direct connect. Let me know. So this is actually NLB also. I just created one, right? So NLB, and we have uh, a target group for NLB created, and in that target group, I have two instances, same server and one server two. I told you it's just same, right? So if we come here, just paste that. So this is the uh, NLB URL. If I paste that, it will do the same, right? So it is server two, and it will cycle. And sometimes it becomes little cheeky. So what we need to do is just because of the cookies. So I have to just do this. Sorry, here. Right, it is the cookie, so don't worry, it's working fine. It just somehow sticks. So so this is the same URL, but it is cycling between these two servers. So this is the NLB demo. It's more or less the same, right? Okay, so let's uh, what mm, okay, direct connect. We I don't know. Prasad, shall we? Can we go a little bit over if it's not too long, and we can go through direct connect. What do you say?
Yes, I think it should be fine. Like I know we are over time. How much time is going to take?
Maybe 20-ish minute. I just want to show because this is something you or maybe make we can have a next session and we can go through in detail.
So I'll ask the folks, like, should we have it, because the 20 minutes would be a long time, like, and I think, instead of rushing it, we can have a half an hour session in one of the upcoming session, or do you want to folks to see now? We can provide another 30-minute slot for the next session. Okay, few people are saying next session, please. Obviously, Saturday people will be having, like
Yeah, actually,
time,
and
and they,
yeah, this is in
obviously
concept.
there
I
is.
don't want to rush it because see, for me, I do it day in day out, right? So I may go a little bit with the speed, right, and which I don't want to do, right? So let's do it next time. And yes,
Sure.
and
From the next session, folks, as you know, that we are finishing the technical track, 8 weeks, and for the next session, it is like 4 weeks now. Our uh, behavioral track starting. But what we will do is that we will reserve 30 minutes for Ashutosh in the next session, and yeah, Ashutosh will show the demo of Direct Connect. And in case if there is any other request, feel free to let us know either here or on the LinkedIn group if there's any specific technical topic that you would like us to dive deep into, or any behavioral topic that you would like us to dive deep into. Please let us know, and we will accordingly get the guest speakers, or we'll accordingly try and cover. There's a request for ECS. Okay. Good enough. ECS is a separate topic altogether. It'll take probably a full one session. Next session is Easter holidays. Yes, it is actually for us. Uh, but
mm,
Ashutosh, will you be available next weekend?
oh no, actually, I'm going out.
No,
So,
probably next weekend then.
yeah, yeah,
And
yeah.
so it's
Most of the time I'm available, but my kids' holiday started, right? So we have to go somewhere.
yeah.
But yeah, then I will see. And we have the setup available, right? It is our setup. So let's do it properly because I really don't want to rush. And I have all sorts of resources, workshops available, like hundreds of workshops, and we can have a networking whatever you want to do, right? So don't worry about it, and feel free to share your queries in the I oh, by the way, Prasad, do we have any interaction mechanism, like if anybody wants to ask any question offline, how does it work?
We do have a LinkedIn group, Ashutosh. Let me add you to the LinkedIn Besa group. So we have
Yeah.
around, like, I think 3,000 plus people now, like, and we like keep interacting there. So let me add you there so that you can create a post about all the resources there also. And anyways, we'll be posting it on our, like, GitHub page resources section. But we can start a thread specifically on this on our LinkedIn Besa
uh,
group.
That is great. That's great. Okay, I'm sorry. Somebody asked this. What is the priority value? Sorry, I did not see it. So, see, the priority value is the rule priority. Like how, what is the evaluation order of the rules, right? Priority value, one rule will be evaluated first, then the second rule. So it is just that. It's just a rule numbering, right? Um, and I'm sorry. Apologies in case I went too fast because I wanted to give you, idea about a few things, and I appreciate. See, in case you did not get something, just don't worry. See, I did it for 20 years, right? So for me, it is like everything is kind of in my brain. But if you don't get anything, just don't worry. We can, I'll just guide you through the process, and I'll share some nice workshops from basic to advanced, and you can go through it. And any networking queries, feel free to ask. We already have so much public resources, but just in case you want, please feel free to reach out. And I hope it was good use of your time, and sorry to bother you on the weekend, and enjoy the rest of the day.
No, it was for me. It was a good learning. There are few basic things that I know, but there are few deep dive things that like I was not aware of, frankly. And even for the basic things, it's always good to get a good refresher. So yeah, I think it was, for me at least, it was really useful, and I'm sure it was same for everyone. So, anyways. Uh, Yeah, okay. There is a request on CPU hogging script share. We will do that. Anyways, I'll add Ashutosh to the LinkedIn Besa group, and then you folks can like directly reach out to him. Or anyways, he'll be available on LinkedIn. Anyways, you feel free to message him directly, add him to your network. And as I said, like one of the best networking guys I have worked with. So he's
Oh,
great, technical guru. So thank you everyone for your time today, and see you next week for the session of behavioral. And we will book a slot with Ashutosh for most probably 15th, the week after Saturday, for the Direct Connect demo.
okay, then. Thank you, everyone.
Okay.
Have a
Thank
good
you
rest.
everyone.
Take care.
Take care. Cheers, guys. Bye bye.
Bye.